And let's continue about the relative position between lines. Here are about confounded straight lines. If A equals A prime, as you know, the slopes are equal, and if the y-intercepts are also equal, then D and D prime are said to be confounded. For example, if line D is to y equals minus x plus 4, and I'm going to make it in the reduced form, I make it y equals minus x over 2, which is minus 0.5x plus 2. And the other line, capital D, as I told you, we use letter D in its two cases. And capital D is y equals to minus half x plus 4 over 2. First look, seems that they are different, but indeed they are equal, because minus 0.5x is exactly equal to minus half x, and 2 is exactly equal to 4 over 2. So the slope here is minus 0.5, and here it is minus half, then they are equal. The y-intercept here is 2, and the y-intercept here is 4 over 2, which is actually 2. Then because the slopes are equal and the y-intercepts are equal, we say that the lines are confounded. So here, as if we have a blue line and a purple line over it, then we get confounded lines. And now we are going to talk about intersecting lines. Intersecting lines have no specific rule. They just don't have equal slopes. Whenever lines don't have equal slopes, then they are any intersecting lines. If the product of the slopes is minus 1, then we say that they are intersecting perpendicular lines. But if there is no property relating 8 with A prime, then we say that the lines are just intersecting. Given the example, D is of equation y equals minus 2x plus 1, and D prime is of equation y equals to x. Let's stop a little bit here. What does that equation remind you of? That's a line passing through the origin, because it has the form of y equals ax. Its y-intercept here is 0. So note that when a line has the form of this y equals just a number times x without plus or minus any constant beside it, then definitely this line is passing through the origin. Now look at the slopes. The slope of the first line is minus 2, and that of the second line it is 2. They are neither equal, and nor their product equals to minus 1, then they are neither parallel nor perpendicular nor confounded. They are any two intersecting lines. And here is the purple one is line D, and the green one is line D prime, and as you see here is their intersection point. Notice that D prime is exactly passing through the origin, as I told you, because its equation has the form of y equals ax. Now let's continue to know and to learn how we determine the point of intersection, the coordinates of the point of intersection of a line with the axes, the x-axis and the y-axis. And we'll explain this using an example. For example, here there is a line D of equation y equals to x plus 1. All what I have to do is to calculate the coordinates of A and B, the points of intersection of D with x prime o x and y prime o y respectively. That means this straight line D is gonna be intersecting the x-axis at a point A and the y-axis at a point B, and I'm going to find the coordinates of these points. How can we do that? We must use the help of the figure. Here is like the figure. Here is the line intersecting the x-axis at the point A and intersecting the y-axis at the point B. What does the intersection between a line and the x-axis mean? D cuts x prime o x at a point A means that A belongs to the x-axis. What does that mean? What does a point belong to the x-axis mean? It means that its ordinate y is definitely 0. So any point on the x-axis has no ordinate. Its ordinate is 0. So I know ya. It is 0. I still have to know xa. Now a also belongs to d. So d intersects x-axis at a. Then a belongs to the x-axis and a belongs to the line as well. Then, since a belongs to d and I know that y of a is 0, all what I do is to evaluate in place of y, ya, which is 0, and 2 remains as it is. In place of x, I put xa plus 1 as is written here. So I have to find now, I have that ya is 0. I still have to find xa. All what I do is some calculations, taking one to the other side and dividing by 2, then I will get that xa is minus half 0. So the point A, which is the point of intersection between the line and the x-axis, is minus half 0, and this point A is called the x-intercept because it's the point of intersection between the line and the x-axis. Now, we have also to find the coordinates of B. Let's recall, what is B? B is the point of intersection of this line with y-axis. Then definitely, B belongs to the y-axis and B belongs to D at the same time. So, B belongs to the y-axis means that B goes neither left nor right. Then x of b is 0. So any point on the y-axis has an abscissa that's equal to 0. You have to keep this in mind. But b belongs also to d. Then I have to substitute in the equation of d. I put yb equals 2xb plus 1. What do I have? I have xb. So I still need to find yb. Then yb is the missing. And I evaluate x of b, which is 0, then I will get yb equals 1, and thus b is of coordinates 0, 1, and as you know, b is called the y-intercept. Now, this is how to determine the point of intersection between a line and the x-axis or between a line and the y-axis. Now, how to determine the point of intersection between two lines among each other, not just with the x-axis or the y-axis. And here is also an example, because we have to explain these ideas using examples in order to make things simpler and easier. Given the lines D of equation y equals 2x plus 1 and d prime of equation y equals minus 3x plus 6. We have to calculate the coordinates of the point A, the point of intersection of D and D prime together. Then definitely these lines are intersecting. Let's make sure no equal slopes, then they are never parallel. The multiplication or the product of the slopes is not minus 1, then they are not perpendicular. Even if they are perpendicular, they are intersecting as well. So if they are not parallel, so all what we have to maintain is that the slopes are not equal. Then to make sure that they are not parallel, then they are intersecting. Now, how can we solve this? We just put y equals y. It's a very, very easy way. So line D is like y equals something, and line D prime is y equals something too. So we just put y equals y. We can put it y equals y or ya equals ya, whatever. Then 2x plus 1 from the first line is equal minus 3x plus 6, or we can put 2xa plus 1 equals minus 3xa plus 6. So again, I am comparing, I'm using a comparison way, because y equals y, then surely this value is gonna be equal to this value. Now I have an equation with one variable only, which is x. I can solve it. Taking x together and the numbers together, I get 5a equals 5. Then definitely xa equals 1. So again, I collect x together and take the numbers together, then I will get 2xa plus 3a by taking it to this side. And I have 6 minus 1. So 5xa equals 5, then xa equals 1. Now I found xa. How can I find ya? I just evaluate this value xa in one of these equations, either in D or in D prime. So I can evaluate in D or in D prime. I chose D here. So ya equals 2xa plus 1. I have xa, which is 1. Then I evaluate. So 2 into 1. In place of xa, I put 1. And I will have 2 into 1 plus 1, which is 3. Then the point A is 1, 3. Here is the figure that let me be sure that A13 is the point of intersection. Look, the green one is D, the violet or the purple, whatever one is D prime, and their point of intersection is clear that it is A of coordinates 1 and 3.